All right, so I'm going to hand out your chapter test study guide. And this is kind of what we're looking at tomorrow. I want to make sure we get through this today so that when we leave here, we're in good shape and feel pretty good about tomorrow. But again, I can't stress enough how great of a start you've gotten off to. And just keep going in the right direction with this stuff, okay? All right. So here we go. Study guide. Those fixed already. I'm going to get those in a second, okay? So a lot of stuff about density relative to area, density relative to volume. There'll be some cross sections in here, which I thought you guys did a great job on. There'll also be some solids of revolution. And I think if you can understand today, we're going to be well prepared for tomorrow. Okay, fixed already. Well, this is the best I can give you for a present on your birthday. So happy birthday. It's a good present, isn't it? Mm-hmm. All right, so we're missing Gus, and we're missing Nate and Dakota. Okay, guys, let's get rolling together on this. I think that we're going to be okay on all this, but I want to be sure. So let's get started here, guys. Test tomorrow. How many problems are on there? What's the last problem on the backside's number? 12, so there's 12 problems. I mistakenly said 10 earlier. So let's get rolling here. Guys, the first one's going to be a section 1.1. It says Chautauqua County, New York has an area of about 1,062 square miles and a population of about 135,357 people. New York has an area of about Seneca County, New York has an area of about 325 square miles and a population of 34,724 people. Which county has the greater population density? Tell me why. Well, how am I going to go about this, kids? I'm going to show my hands so I know who's speaking. I have a hard time through masks here. What do I need to do on this one? Haven? Were you volunteering an answer or just talking?
I was half talking, half speaking.
Okay. Well, I'll help you through it, guys. What's your formula for density again in terms of population? Yeah, population over what? Okay, so I'm going to kind of divide this into two parts. Let's do, is it okay if I abbreviate Chautauqua County CC? Is that okay, kids? Okay, how are you going to find the density of Chautauqua County, kids? Stone? Yeah, so what's the population there in Chautauqua, kids?
135,000.
And then how about over the area? 1,062 square miles. Okay, we'll see what that number equals here in a second. And then how about what is it, Seneca County that we have right here? Abbreviate SC. What's the population of Seneca County, kids? 34,724 over. Okay, do I have a volunteer that would run this number on the left? Let's go, say, two places for population density. If I do that 135, who's going to do Chautauqua County for me? Who wants to punch that in for me? You got that one? Maddie, will you do the other one for me then? Haven, what'd you get for Chautauqua County when you take this population divided by the area?
127.45.
127.45, and that would be people per square mile, right? Okay. Maddie, have you got the other one for me there, kiddo?
106.84.
106.84. So I haven't put any units on this yet, but we understand that this is people per square mile, right? So the question becomes, which county has the greater population density? What would you say here, kids? First one here, Chautauqua, right? There's more people per square mile or per unit area than there are in Seneca County. So, trying to squeeze this in here. We found the two population densities. So we need to bring some closure to this with what they want. Your greater population density is in, what do we say, Chautauqua County? I'm going to abbreviate CC. Okay? So tomorrow that's probably looking like a 3-point problem. Find me the two densities and then make your comparison. All right? Very good. Okay, number 2, we've kind of talked about this a little bit, but before I run on to number 2A, everybody have everything down on the first one? Any question about the first one? It's just simply finding density and then make a comparison. That's really what you're doing, okay? All right, we've seen problems like number 2 in the past. It says about 154,000 people live where? In a circular region. This, you should have red flags going everywhere saying, ooh, my area is what shape? It's going to be a circle, okay? Keep that in the back of your mind. It's got a population density of what, kids?
2150.
Okay, 2,150 people per square mile. Good. What are we trying to find? Okay, here's the deal. If I didn't know where to start, if I had zero clue where to start, I at least know we're dealing with a density problem as it relates to area. Would you agree with that? So we know that the density is going to equal some population. Whoops. It's going to equal some population over my area. Okay, let's plug in what we know. Do we know the density, kids? What is that density value? What's going to take the place of D? Yep, 2,150. It says right here you have a density of 2,150. That's going to take the place of D. Here we go. Do we know P? Do we know the population, in other words?
Yeah.
What's that value?
154,000.
Okay, now I could, kids, do this a couple of different ways. The thing that we don't know is the area, but the question is specific to what shape for an area. So instead of putting A down there, what might be a good thing to put down there for this? Say it again. Max says pi r squared, and the reason being, Max, area of a circle's formula is absolutely pi r squared. And the nice thing about this is it puts r in there as our unknown. R is our unknown. Say, oh, okay, no problem. That helps us find the what? Yeah, let's figure this out, kids. Now, I don't like the way that this is set up. I might put this 2,150 over 1 and say, ooh, that's like a proportion. So let's cross multiply and divide. So help me with the math on this, kids. One cross product is going to be 2,150 times pi times r squared. So I need someone to punch 2,150 times pi up for me. Somebody do that for me. 2,150 times pi. We'll go 2 places on that.
6,754.42.
Thanks, Maddie. 6,754.42. That comes from the 2150 times the pi. What do I need to put behind this value, kids? R squared. Oh boy, help me guys, it's Monday. 1 times 154,000 for that cross product. Yep. Guys, you get this far right here, it's pretty much a 2-step equation. So what's your next step in solving? Not subtract. It's a times r squared. Divide, you bet. So divide 6,754.42 on both sides. Good. I need to make some room, so give me a second. Okay. Left side going to be r squared. How about the right side? What's that going to turn into? 22.8. Everybody agree 22.8? Okay, am I done? So what's my final step? Okay, Haven, how'd that go again? No, you were doing. I like that. Okay. What is that approximately, kids?
4.77.
So the radius of this circular region is about 4.77 miles, right? Again, we've talked about these density problems. If you don't have any idea where to start, at least start with the what? Start with the formula, exactly, and then plug in what you know and say, guys, why did I put pi r squared down here again instead of a? It's a circle. Okay, we need the formula for circles there then. Okay. All right. Give me a show of hands. First two. Are we okay with it right now? Any questions? First two at this point. Absolutely. Yep. And I'm going to go with that here on 3 and 4 here in a second. I assume you're talking about the formulas and stuff like that, right? Is that what you're after? Yep. We're going to talk about that in number 3, actually. Good question. All right, have I need more time with the first two? All right, roll on 3. Here we go. Kids, down here it says, describe how the change affects the surface area of the pyramid or prism. Guys, in this case, what do we have? Have a square pyramid, right? Now, kids, there's 2 ways to go about this. Some of us have caught on to this idea. First of all, are we dealing with an area or a volume in number 3? Surface area. And it talks about saying, okay, if I'm talking surface area right here, it says, what's the effect of multiplying all dimensions by 1/3? Anybody think they know the answer to this without doing any computations?
1.7 times.
Say how many times again, Max? It's for an area, not for a volume.
9 times smaller.
It's going to be 9 times smaller, exactly. But that only works because we're applying changes not to some of the dimensions, but all linear dimensions, okay? I'm going to write down here, Max is saying, well, I know that I'm changing all dimensions by a factor of 1/3, so 1/3 to what power? What power really involves area, kids? Or what kind of units are you dealing with area? Okay, so if we were painting the outside of this, there would be a certain number of square units I would paint for this original figure. But if I said take all the dimensions by 1/3, well, 1/3 square units would equal 1/9. Max is saying the new one would be 1/9 the original surface area. And I'll abbreviate surface area as SA. Now, kids, and Haven brought this up over here, and I want to put Haven's name to this one. Haven, you said, can we still use those things? What were those things again? Yeah. So let's look at it this way, maybe. Is that bottom base a square, kids? Okay, so I'm going to type in surface area of a square pyramid. Is that okay? All right, do we have the interior height on that example? We do. What is that interior height, kids? And then the base length down here is, okay, so let's look at it this way. Let's say that I didn't get that concept right away. What I could do is be like, well, I know that the base edge down here was how many units? Was it 12? And what was that interior height again, kids? 27, okay? Somebody remember that number right there. The original surface area on the outside is 807.81 units, okay? Now the question becomes this: how does the surface area change if we multiply all those dimensions by 1/3? Well, kids, help me out. What's 1/3 of 12 on that base length? What's 1/3 of 27 for your interior height? What's that number? 89.76, okay? I'm not the greatest mathematician in the world, and I never claimed to be one, but do you guys have those two numbers down right now? Okay, so let's do this. Let's look at it as let's look at it from this perspective then, okay? Haven, what was the original surface area?
807.81.
And what's my new surface area, kids? 89 point how much? 0.76? Okay. Couple of things I could do about these two values. One, I could just divide them out. Take what's new and divide it by the original part right here. Or I could take the bigger one and divide it by the smaller one. I'm going to choose to do the bigger surface area and divide it by the smaller surface area. So I'm going to go into my calculator. All right, kids, 807 point. We'll look at the ratio comparison here. What do I want to divide that by, kids? Anybody got a guess on what this is going to be pretty darn close to? Your calculators and Google and your calculators that we use are going to do a lot of rounding, so I'm going to guess. Are we pretty gosh darn close to 9 times there? Okay, so we could make the relationship that way and say, well, then if the factor between these two is 9, if we multiply all linear dimensions by 1/3, is my figure getting bigger or smaller in terms of surface area? Okay, so the idea that I've got this value 9 when I take the bigger and divide it by the smaller area, this is kind of telling you the same thing right here. So what fraction are you going to have here again? Well, it would be 1/9 the original. Now keep in mind, kids, this only works if you change how many of the dimensions? All dimensions, okay? All dimensions. So again, you could have found it this way by saying, all right, well, this divided by this was 9, so it got smaller, so 1/9 the original surface area. Okay, very good. Questions about number 3 at all? Rolling on here. I want to make sure we get through this today. Okay. Number 4, I think, kind of a tricky one. Guys, we're talking about coins, so what shape should automatically be in your head? A what? I think somebody said cylinder. Yeah, thanks, Joy. You all done, buddy?
Yeah.
Okay. You heading back to study hall? Or do you want to hang with us? It's your call. Okay. It says the United States has minted $1 silver coins called the American Silver Bullion Coins since when, kids? 1986. Each coin has a diameter of how many centimeters? Okay, 4.06 centimeters. And how thick is it? Okay, it says the mass of the coin is 8.5 grams. What is the density of the silver to the nearest tenth? Well, first of all, kids, what kind of a shape do you have? You have a cylinder. Okay, so I'll do my best to draw a cylinder here quickly. Aubrey, can you still see through me? here's my cylinder, and it's a coin, so maybe kind of like this. Is it going to be a tall and thin one, or is it going to be kind of short and wide if it's a coin? Okay, so let me draw this here quickly. Here's the other part of that. And then maybe my sides are right here. Oh boy, I really messed up on that. That would be a funny looking coin, wouldn't it? Whoa. What's your diameter, kids? Okay, so all the way across is 4.06. I'll just kind of put that down here. How about your units in terms of diameter and height? Are they consistent with each other, or do we have problems? Yeah, they're both measured in what unit? So is that a good thing or a bad thing? Okay, what are we asked to find? Density of the what? Okay. Let's see, this is relative to volume, so I'm going to talk about density relative to mass and volume here. Okay, here we go. We're trying to find density, so we don't know what D is going to equal. Kids, do we have a mass for this coin? What is that? 8.5 grams, right? Do you know a volume? No, but we can figure it out. So somebody run into cylinder. Am I talking volume now or surface area this time? You got to know volume. So type in volume of a cylinder. Okay? And when you get the volume of the cylinder, it's going to ask you for a radius and a height. Now be careful on this one, because what is your radius? Yeah, 2.03 is the radius. What's the height? 0.48. So somebody punch that into your cylinder formula for me. Radius of 2.03. Is anybody in that Google thingy right now?
6.21.
I'm sorry, Aubrey, I didn't hear that.
6.21.
6.21. Guys, what kind of unit should I put on that volume here? Cubic centimeters, okay? All right, so calculator-wise, I can run over here, and we're going to take what divided by what now, kids? You're going to go 8.5. Divide that by. Talk to me about density of this coin then, kids. Whoops, I didn't see it long enough. 1 point how much? 1.37. I like it. How about a unit? Awesome. So this is what we should have for a solution right here. By the way, kids, the density of water is 1. Would this coin sink or float if I threw it in? Sink. What would your reason be? It's heavier than water. It's more dense than water. Things that are more dense are going to sink. Okay? All right. Very good. Number 5. I'm going to go on the idea that we talked about up here with number 3, but this time it's relative to not surface area, but relative to what here, kids? It says describe the change. What's that change do to the volume of the cylinder? What are we doing to all these? Quadrupling all dimensions or some dimensions? If it's all dimensions, then that'd be like saying take 4 to what power? Well, what is 4 to the third, kids? How many times? Okay, it's 64. So I would say the new cylinder would be 64 times bigger. By volume. Now again, kids, if I wasn't sure, couldn't I find the volume of this one right here? Use that value to find a value of the volume. And then once I knew that value, couldn't I quadruple my dimensions and find that value? And then run a ratio? But the thing is, it talked about changing how many of the dimensions? All of it, okay? All right, moving on. I'm not going to do that. I think you guys get that concept. 6 says the mass of a block is what? And our density is this. What's the volume of the block? Well, no problem. Use your formula again. Density equals mass over volume. Let's roll. By the way, check out your mass. How is mass measured? Kilograms. How about the mass part of my density? Is that measured in kilograms? Are we good on units then? All right. Be careful. I don't know if I'll see any problems that have conversions or not. But what's going in for density? I'm already messing up, aren't I? What's going in for density? What's going in for mass, Kylie? I don't know my volume. How are you going to solve for volume, kids? Can I make this a proportion now? Cross multiply and divide. Okay, so somebody punch that up. Run that number for me. Cross multiply and divide. Okay, let me come back to this. Say that again, Kylie. How many 51.4? 151. Okay, I just didn't hear the first part. Guys, how about the volume unit? What volume unit was measured in the density part? So cubic meters for volume, right? So far, so good? Seven. If anybody misses 7 and 8 tomorrow, I'm going to be upset, okay? Describe the shape of the cross section formed by the intersection of the plane and the solid. Kids, if I run a horizontal intersecting plane through this cylinder right here, what kind of cross section is shown? Anybody? It's a rectangle. And guys, we've looked at vertically intersecting a plane with a square pyramid in the past. What shape is formed over there in that cross section? Trapezoid, okay? Those are gimme points, I think. Okay? Anything stand out on the first page that you're just not 100% sure of? Anything you want to question right now so far on the first page? Just showing hands, how many feel pretty confident with the first page right now? Okay. All right, let's look at the back side here. Oops. Guys, I'm going to probably tomorrow on the test, it says sketch the solid producing by rotating the figure around the given axis, then identify and describe the solid. You know, if your sketching is kind of like mine and you struggle with it a little bit, if you can put into words what that should look like. You have a rectangle adjacent to a vertical axis. If I start rotating it around this axis, and I should have probably put this in here, say, listen, we're going to rotate it around this axis like so. What shape is going to form when I rotate a rectangle around a cylinder? Okay. And if you just write the word cylinder tomorrow, I'll be like, you know what, I'm okay with that. Okay? Or if you want to sketch it, make an oval up top here, an oval up top here, an oval on the bottom here, and then, you see, do you understand why I say sometimes if you want to use words instead of, how many are like me? Just art is not their thing. Is there anybody in this room? I am challenged when it comes to drawing. Whoops. I'll try, well, come on. There we go. So you guys get the idea. It'd be a tall, skinny cylinder if you rotate it around that axis. All right, very good. I'm okay with that. See, Okay. Guys, number 10. I want to pay some attention to number 10 here. I think that there's some important concepts in here. I'll blow this up a little bit so I can see this better. All right. First thing it says to do is sketch and describe the solid that is produced when the region enclosed is bounded by certain lines. Let's first of all figure this out. What lines are we going to use to enclose a region? What's the first one up here, kids? Okay, y equals 4. So on the y-axis, I'm going to jump up to 4, and we're going to draw a horizontal line through that. Okay, y equals 4 would just be a horizontal line like this. Okay, what was the next line up there, kids? Okay, x equals 0 is which axis? Y-axis. Good, Chase. Here's my second boundary line at x equals 0 on the graph. Okay, what's the third boundary line? Y equals what? So in slope-intercept form, where would your intercept start? This is like 2x plus how much? 0. And so 0 would be the y-intercept to start at. And then how about the slope to that point? Rise 2, run 1, right? So your line is going to it's going to start right here at 0 at the origin. Then you're going to rise 2 and run 1 to form that boundary line. So what I want to do, I want to sketch a line that's going to show that. So let me go up to 5 here. Okay. First question. We only had 3 lines to graph. Is that true? Okay. What shape is going to be enclosed, or where's the enclosure show up at with those 3 lines? It's a triangle right down here, right? And on this triangle, kids, you're asked to rotate around what? Okay, so we're going to rotate this triangle around the y-axis like that and say, all right, find the value of the what? Okay. Well, guys, if we're rotating around the y-axis, and maybe I should answer the first question down here, what shape's going to be formed? Okay. And if we rotate this way, what's this distance up here? Is this a radius or a height? So this right here, this distance will be a radius of what value, kids? And then how about the height, kids? Be careful on the height. Starts down here and goes all the way up, which would be 4, right? Okay. Who's in the volume of a cone calculator for me right now to throw those values in? Or if you just wanted to pull the formula there and plug your values in, that would work.
16.76.
16.76. And as we're talking about volume, kids, we would probably call it 16.76. What type of units, kids? Maybe cubic units? All right. Okay. Whew, we're getting close. 2 more to go. 2 more to go. We're going to get this done, and I'm going to get you out of here. Reminding you that you have 1.3 and 1.4 due at 10 o'clock tonight and 10 o'clock tomorrow. Test will be tomorrow. I feel very confident we're going to do well. Anybody need more time with these 2 examples? Okay. Volunteer to read 11 for me.
You have a carrot cake with a radius of 8 inches and it is 5 inches thick. Put the cake horizontally and make a few contours.
Okay, so what shape is this if we're talking radius and height? Cylinder. So I'm just going to do this again. Quick draw cylinder. So here it is. Here's my carrot cake. Anybody ever eat at Village Inn?
Yeah.
Oh, anybody ever have carrot cake at Village Inn? Highly recommend it. Okay. All right, here we go. So we're assuming cylinder. It says you cut the cake how first, kids? So there's going to be a plane going through here horizontally that's going to cut this. So a horizontal cut. Kids, if I can imagine a horizontal cut going through here, think about that cylinder. If you cut that horizontally and then pull the top half off from the bottom half, what kind of cross section would you form? Be careful on this one. Maybe we're cutting horizontally this time, right? So it's going through this way. So if this was my rubber band around the cylinder like so, I don't know, it'll be a circle, right? Okay. So in part A, the cross section would be a circle if I cut through there. Okay, talk to me about that circular cross section, kids. They want the perimeter and the area. Wouldn't the perimeter just simply be a circumference? Wouldn't the circle, the perimeter around that just be a circumference? And that formula is found by taking pi times diameter. Kids, what would the diameter be in this situation then? 16, because right up here it said your radius was what? Okay, so you want to go pi, your perimeter is equal to pi times 16, gosh, 50.24-ish.
50.27.
27, okay. And that would be inches. How about area of that cross section, kids? What's your formula for the area of that circle? Pi r squared. And what's the radius there, Chase? So pi times 8 squared. So 201.08, somewhere in there.
201.06.
201.06. Very good. And that would be cubic, or I'm sorry, that would be square inches for a cross section of an area. Okay? Now, here's the different part, and I don't know who said rectangle earlier, but if I cut vertically, then what would the cross section look like? It would be a rectangular cross section, wouldn't it? You all good with that? Yeah, rectangular. Okay? If you cut it rectangularly or vertically right down the middle, okay? Make two congruent parts. What is the perimeter and area of the new cross section formed? Well, if you cut this vertically, it would be a rectangle. The top part would be like the diameter all the way across here. What was my diameter, kids?
16.
What was the height still?
5.
Okay, so we need a perimeter and we need an area here, kiddos. Perimeter. And your area. $80. Okay. Got about 6 minutes left here. Get this last one done. Guys, I think we're going to be in good shape tomorrow. I really feel good about this, okay? Guys, I just want to come back to 11. Are you clear on the cuts right here? And trying to visualize which cross sections are formed when we cut this. And when I say what is the perimeter, what is the area, they're talking about the perimeter and the area of the cross section that's formed after the cut. Show of hands. We okay with that one? Hands if you're good. All right, excellent. Hey, last one here. Last one. It says describe the sound produced by rotating a figure around the given axis and then find the volume and what? Find the volume and the surface area. No problem. What shape's it going to be, obviously, kids? It's a cone. All right? So punch your stuff in for a cone. What are you going to use for a radius?
4.
Okay, radius is going to equal 4. How about a height in this?
7.
Okay, somebody want to run? Who's going to volunteer surface area when we search that? Surface area cone with radius 4, height 7. Who wants to run that through for me?
I got it.
Kylie's got that. Who's going to do volume for me? Volume of a cone for me with radius 4, height 7. You got a surface area there for me, Kylie?
151.58.
751.58?
151.
151. And that would be square inches. Can you run a volume on that while you're in there for me?
117.29.
Thank you, Kylie. Kids, I don't know. We went through that. I don't feel like there was too many questions or anything like that. So I would say make sure you're aware of what's there for tomorrow's test. Bring your notes with you. Make sure your Chromebooks are charged. I know that you guys said no questions on the online assignments 1.3 and 1.4, so make sure you get those turned in on time. Otherwise, be prepared for first test tomorrow of the year, and I'm looking forward to seeing you guys do really well on that, okay? Questions at all? Going once? Twice? All right, you guys, be ready to do well tomorrow.